In case you are saying from one room or one room self-con, and you need a solar system, and somebody's telling you must buy 10 panels, 20 panels, or big batteries and all that. So these are the things you need for the system. Solar system for one room for 6 or 12 hours. So in today's video, I'm going to look on the size of solar system that we need to power our basic home appliances for one room for 6 or 12 hours. So if you are the one that is tired of NEPA or tired of blackout of everyday generator and you want to go into solar, but you think solar is expensive and you think maybe you must have plenty of solar panel or you must have a huge amount of money before you go into solar, this video is here to clarify everything for you. And if you know you are that kind of person, stay to this end of this video. At the end of this video, you discover a solar system that you can use for one room or one bedroom. So in this video, we are going to see how we can discover outside solar system we are going to use for one room. So if you are that type, let's analyze the system together. But before then, it is very important that you understand that when you are powering, when you need solar system, you think of the load you want to power, you think of the appliances you want to use, because that's the determining factor of any solar system you want to use. So in today's video, we are going to look into the size of our load, the capacity of our load. We'll look into the size of our inverter, how many panels do we need, and how many batteries we need. So we are going to do it practical, because you will know that in any room or in any house, there are basic home appliances. And what are those basic home appliances? This is what we are going to look at in this video. Then we are going to size our load based on what we use in our house. For one room, at least we need light bulb. There will be a fan, at least one fan. There will be a TV and charging of phones and other basic home appliances. So this is what I'm going to lay out on this video. And watch this video and you will see clearly how I'm going to size this system for one room. And at the end, you can come up with your own maybe budget or how you can go about it and get the solar system for yourself and stop living in dark areas or blackout or frustration from NEPA and noise of generators. So we do a breakdown today to see that, okay, what size of solar system we need to power our basic home appliances if you are staying in one room for 6 hours or 12 hours. So this is what we are going to be looking into in today's video. So we can see from the appliances over here, this is the total sizing and the breakdown of the systems. Then you can see from the up here, I have appliances in the house. In some people that stays in single room, or let's say a room self-contained, you might have a minimum of 4 bulbs of 10 watts. This is quantity, this is watt, this is total watt, this is hours, which is the duration. Maybe you want this system to on, you want your light to be on for 6 hours, you want to be using your TV for 6 hours, you want to be using your fan for 6 hours, and your laptop and phone charging for 6 hours. So these are the systems that we'll look into, and we get our total wattage and watt hour to size our solar system, so that you will know the size of inverter that will power this load and the battery that can carry this load for 6 hours. So this is what we're going to look into, and this is the breakdown. So number one, we have the LED bulb, which is our quantity of the bulb is 4, then the watt is 10. So we multiply 4 times 10, give us 40 watt, which is the total watt. Then now we have 6 hours. We multiply 40 watts times 6 hours, it gives us 240. This is watt hour. So this is how everything is being calculated. And here we have 32 inches LED TV. We have one, and the power consumption is 100 watts. Then if you multiply 1 times 100, give you 100 watts. Then if you multiply 100 times 6, we give you 600 watt hour. This is also for fan. We have one fan, and the power consumption is 90 watts. Then the total is 1 times 90, give us 90. Then multiply 90 times 6, gives you 540. Then this is also another for laptop. We use 90 watts to size for our power consumption of laptop. Laptop, we have different sizes of laptop, but we are just using 90 watts as the power consumption for the laptop. Then we multiply 90 times 6 to give us the same thing, it's 540. Then we have phone charging. This phone charging can be one power bank and one for maybe one person staying in the place. And we have 30 times 6, it gives us 360. So we are going to use the total watt hour to size our inverter. Then we are going to use the watt hour to size our battery bank. So when we calculate everything and sum the total watt of all the appliances we have in this place, it gives us 380 watts. Then when we calculate all the total watt hour after multiplying by 6 hours each day, now we are going for 6 hours. Then at the end, we'll be doing for 12 hours so that we'll know the hours that the system can last on the system. And if you want need 12 hours, you can know the size of all the solar materials, all the devices that you will buy that will power your home for 12 hours. So at the end of everything, we got our total watt is 380 watt. Then our total watt hour, this is 1980 watt hour. So we'll be using this system to size our inverter. Then we'll be using this one we'll use to size our battery bank. So now let's go into the details of how we are going to get our inverter size from this breakdown, and we're going to get our battery bank from this breakdown. All right, so now we are going to see the size of our inverter. You know, inverter is the one that is responsible to power your load, while the battery is the one that determines how long those appliances will be powered for a period of time. So now it is important that if your inverter cannot power your appliances, your solar system will not last long and will not be effective. So in other words, we see that your inverter size is very important in determining the size of solar system you need in your home. So in this place, from our previous calculation, we see that our inverter, our load total is 380 watts. 380 watts. Then we use this 1.25 as our safety margin, because when you want to use inverter to power anything, or you want to on this solar system, you give tolerance, because inside the system there are things that might want to overpower the systems, or you might want to bring extra things, or we don't have this kind of inverter in the market. That's number one. Number two, you cannot use this capacity of inverter to power this load, which is 380 watt inverter, to come and use it on 380 watt. It doesn't work like that. The inverter will trip up because it cannot carry such amount of load. So in this place, we see that this is 1.25. We use it as our safety margin to do what? To add it up to our size of inverter. Then we add it up, it gives us 475 watts. Then after then, we don't have this kind of inverter in the market. We don't have this capacity of inverter in the market. Then let's take now 500 watt, maybe circuit inverter, or the best recommendation is let's just go for 1 kVA solar inverter. It might be transformer based, it might be hybrid inverter. So now we are done with selecting our inverter type. So the second thing we're going to is our battery backup capacity. Now from our previous calculation, we see that our total watt hour gives us 1980 watt hour. If you approximate this, we approximate it to 2 kilowatt hour. That is the size of the battery that we need, a battery bank, to power the load for 6 hours. Remember, we are calculating for 6 hours before we go over to 12 hours. So our total battery bank to power everything in that calculation for 6 hours, it gives us 1980 watt hour, which is approximately 2 kilowatt hour. Okay, now let's go into the battery proper. So remember, we have two types of battery. We have tubular battery, we have lithium battery. But now let's talk about the tubular battery, which is also the gel battery. So in this place, the tubular battery that we have in the market, we have 12 volt, 200 amps hour, we have 12 volt, 220 amps hour, we have 12 volt, 230 amps hour and above. But now let's keep it as average, as minimum of using 12 volt, 220 amps hour battery. Now, if you want to get the total energy of the battery, total capacity, you multiply the 12 volts times 220 amps hour, which is you multiply your voltage times what? Current. It gives you what? It gives you the total capacity, which is the power. We give you the total capacity power. Also, the energy of the total capacity of the battery. Now, we see that multiply 12 volts times 220 amps hour, you give us 2,640 watt hour, which is, if you want to convert it to kilowatt hour, it's 2.64 kilowatt hour. That is the total capacity of a one tubular battery of 12 volt, 220 amps hour. So, but now we all know that, or if you have not known, you have to know it now, that on a battery, there is a way they design the battery to be. It is designed to be 50% DOD for tubular battery or gel battery. Acid lead battery are 50% DOD. And now we can see that 50% DOD means that the battery, if you have a battery that is of full capacity, This is 1 to 100. Then this half is 50%. So from the manufacturer design, it's telling us that you should not drain the battery below this point. You can drain from here up. So when you get to this place, you have to shut down the system so that the battery will not overdrain. So this is how the battery system is redesigned. But sometimes the battery can go down to 60-70%. But to be on the safer side, that is why it is good to use it to 50% and let the system be off, or you off your system so that the battery will not overdrain. So when we see that the DOD of the tubular battery, which is the gel battery, is 50%. But let's consider using 60% of DOD. Now, 60% is 0.6. So 0.6 times the real capacity. Now, to get the usable capacity that we need it from our battery, let's use 0.6 as our DOD. Use 0.6, multiply times this, the total capacity of the battery, to get what? To get the usable energy. Now, the usable energy from the battery will give us 1,584 watt-hour. Then we can say, okay, it is approximately, or let's just say it is 1,005 kilowatt-hour. This is 1,584 watt-hour. But this, if you want to equate it to, I just say it's 1.5 kilowatt-hour. This is what the lithium battery we use. This is what the gel battery is all about. But let's say if we are using this, remember our total, let's come back to our total watt-hour of what? Our battery. It gives us, from our previous calculation, our total watt-hour we need to power those loads for 6 hours straight is this capacity of battery. Now, this is the capacity of battery, 1,980 watt-hour, which is this. Now, we have this as our what? Our real power from one tubular battery. In case you want to use a tubular battery, maybe you want to ask, can one battery power this load for 6 hours? Or how is it going to look like? Okay, so I want to explain something clearly. In case you want to get one tubular battery to power those loads for some number of hours, even if not up to 6 hours, but closely to 6 hours, here is how to go about it. Now, if our total battery watt-hour giving us 1,980 watt-hour. Now we calculated with our DOD using one tubular battery of 220 amps hour. It's not giving us 1,584 watt-hour. Now, if you minus this from this, it will give you 396 watt-hour. This is your result. If you minus this usable battery capacity from the design that we have earlier, it will give you this. So we now find out that the energy needed to power this load for 6 hours to add up to that tubular battery is 396 watt-hour. So, but I want to say something here. If you really want to maintain it, you might not run all your appliances for 6 hours. One of the rules of energy management is that whatever you are not using in the house, you can off it. You might not be needing, you might not need to use the television for the 6 hours. You might not need to use everything in the house for 6 hours. So in those times that you will be switching some things off from the house, you can be able to conserve the energy, and the one battery can be able to serve you for that 6 hours or close to 6 hours. So if by this now, if you want to go for 12 hours, you know that you are adding up another battery or increase it to a higher capacity to last for what? 12 hours. So, but with one battery, which is tubular, if you are going for tubular, you see that you can power for 6 hours. But I'm going to talk about between tubular battery and lithium battery, which one is the best and which one is advisable to go for in the long term. So let's go over to see how tubular battery and lithium battery works, their lifespan, their life cycles, their way of discharge, and which one is the best for us to use. But for those that are budget friendly, you can decide to go with the cheaper one first and the easier one later, you go for the other one. All right. So in this place, let's look into the difference between tubular and lithium battery. So among other differences, we are going to look at some of the difference between these two types of battery, which is the tubular battery and the lithium battery. These are the two batteries that we use in solar system. So it is of important that you understand these two batteries because they don't work the same. They don't last the same. They don't work the same. Their principle of operation might look similar or might be a little bit almost the same, but there are some things that are different when you want to consider either of them, using either of them for your installation or in your home or business places, or consider going into solar system. Number one is their lifespan. The tubular battery, which is the lead acid battery, the lifespan is 2 to 4 years maximum. Unless if you maintain that battery or that system very well, if you are not too using it to drain down to 70% or 80%, you might be lucky to have it up to 3 to 5 years duration, which is this is the time that if the battery will last you, then before the battery will completely go down. Then with lithium battery, under lithium here we have the lithium ion or the lithium phosphate battery. The lithium battery we have it in lifespan of 7 to 12 years. That is, this battery can stay up to 7 to 12 years, minimum of 7 years. Then even if you maintain it very well, it might go above 12 years. So this is one of the best things when it comes to lithium batteries, their duration, their lifespan. Then their depth of discharge, which is the most important thing that we consider when we are sizing a solar system for energy efficient and for battery backup time. The depth of discharge, the only you are seeing is the usable capacity, usable energy that is needed from the battery. It's not that when you buy a battery, you expect that you will draw everything from the battery. It doesn't work like that. There is the usable energy or capacity that you will need from that battery, or the battery can give you. Then the DOD of the lead acid battery, which is tubular battery, that is popularly known as tubular battery, is 50%, which means it's half of the capacity of that battery. Then the 80 to 90%, 80 to 95% is for what? Lithium battery. Lithium battery can drain down to 80%. Some brand can drain up to 85%, 90%, even up to 95%. And this is one of the best things about lithium batteries. Then their life cycle, tubular battery, lithium lead acid battery life cycle is lesser, while the one of lithium battery is higher, which is about 4,000 to 12,000 life cycles of lithium battery. Then let's look into another difference, which is the price. Lead acid battery, which is tubular battery, are cheaper in price. Then lithium battery are expensive. They are higher in price. So let's look into another thing, is the duration. We are going into solar. You consider buying a tubular battery, maybe because of budget. You should put at the back of your mind that the lifespan is not more than 4 years, maximum 4 years, if you maintain the battery or the system very well. Then it is short term. It is cheaper, but it is of short term budget or system. Then the lithium battery it will last for you about 7 to 12 years or above. Then you have more energy draining from the battery, more usable energy from the battery. Then it's a little bit expensive compared to tubular battery that is cheaper. Then it is of a long term. So we use it for a long period of time before we not think of changing that battery. But if you come to tubular battery, it will work and serve you for the meantime, but it is of a short term. So these are what the 5 things. These are some of the 5 major differences. There are other differences when it comes to tubular battery and lithium battery. There are other differences, but these are the major 5 things that we can look into in this system to know about batteries and how effective they are and how they can serve you. So when you are considering going for battery, you look into this and see if you are going for lead acid battery, tubular battery, or lithium batteries. Because sometimes when you go for tubular battery, you will see that you might have changed your battery 2 or 3 times, and somebody that goes for lithium battery is still using his battery. So if your budget for now is for tubular battery, you can go ahead and use it, while you can think of upgrading within time. Then if you have money, you go for lithium battery, it is the best option. So anyone you go for, you will still enjoy your solar system. But when you go for lead acid battery, just put it at the back of your mind that you get to change that battery in the space of 2 or 3 years or 4 years maximum. If you go for lithium battery, you will have enough time to plan. If you plan for changing of battery, on changing of anything concerning battery and all that. And one more thing, let me add another thing, is that in tubular battery, it requires regular or often maintenance. Because as the battery is working, as it's charging and discharging, it requires maintenance. That's where you see the acid level or the distilled water level is low or is dropping. You have to do what? You have to be topping it up, and you have to gauge it to make sure the acid level and all the distilled water level comes up for optimal performance. But the lithium battery require little or no maintenance, because the lithium battery have a BMS system, which is battery management system, which is the BMS. So the BMS helps to balance the system and helps to makes the battery to deliver more energy to you. And the BMS is there to work on the system and to also give you the real capacity and the details of the battery, the percentage of the battery and everything, and how the battery is charging, what is the state of charge, how much the energy you have consumed from the battery, and all of that. So the BMS on the lithium battery is one of the most important things that will help us to get the details and information from the battery even being in use. So it's very important. So these are the 5 difference. These are the 5 difference and more between tubular battery and lithium battery. So when you're going for anyone, you know for what you're going for. Especially for these are systems that will be lasting for 6 hours or 12 hours. Now, if you go for that one battery, we have a lithium battery of 12 volt, 100 amps hour. We have it in 12 volt, maybe 150 amps hour or 200 amps hour. The price might be a little bit expensive, but if you go for this or this or this, it will last you more than 6 hours, going to 8 to even 10 or to even 12 hours, where you manage your energy, where you manage your battery on the energy you are draining from it. You can decide to achieve this number of hours from the lithium battery. But the tubular battery is limited because you drain half or highest 60% and your system will shut down. So let's go into the number of panels you will need to charge. If you are going for lithium battery, tubular battery, if you are going for tubular battery 12 volt, 220 amps hour to power the load for less than 6 hours, you will not check how many solar panels you need to charge that battery in the space of hours, maybe 2 hours, 30 minutes, or 3 hours, 4 hours, 5 hours. The maximum number of sun we have in Nigeria is what? 5 hours. So we cannot go or do design beyond 5 hours in getting our battery charged during the day. So let's go into the aspect and see how many solar panels we need, the wattage and the number of hours we need to charge our battery to the fullest. Okay, so in this segment, we are going to look into how many solar panels do I need to charge my solar battery. So from the beginning of the video, we have looked into the total capacity of our load, of our appliances, and the rated energy we needed to power those things from our battery. So remember, the energy we needed after using our tubular battery, for an example, using one tubular battery, we arrive at 2,640 watt-hour. But now, how many panels can we use to charge this one tubular battery for maybe 3 hours, 2 hours, 4 hours, thereabouts? So this is what we'll be talking about in this part of this video. So remember that average usable panel output is 70 to 75 due to losses, because the more the solar panel heats up, the more it is exposed to sun and heat, it will reduce the efficiency of the panel. You can't get the total. For example, you can't install 300 watt solar panel and get the real power of 300 watts when there is sun, when the panel is exposed to sun and the panel is working. There must be reduction from what? From the panel. So the average percentage of each panel on the roof that is working or exposed to sun that is working is 70 to 75 of the rated power. So put this into consideration. Now, the next thing I'm going to look after is that battery is used down to 40%. Remember, I said our DOD, we use our DOD as what? 60% instead of 50%. So in this aspect, our battery state of charge will be 40%. Because when you use 60%, if your battery was 100%, you use 60 to remain 40. So when it remain 40, we need to charge the battery. We'll start charging from 40% down to 100%. So let's say our battery the battery has been run down to 40%. We want to charge it back to 100. So charging from 40% to 100%. So state of charge is 40%. Then we are going to 100%. Then remember, tubular battery 12 volt, 220 amps hour. The battery capacity of everything, the total capacity in that battery is 2,640 watt-hour, which is this total battery capacity. Then, if we calculate the 60% of this battery, 60% of this 2,640 watt-hour, it will give us 1,584 watt-hour. Now, assuming, remember I said the average solar panel output power is 70 to 75% of rated power. So Assuming we are bringing in 600 watt and 600 watt efficiency will drop because of this our usable panel output. So assuming we are using 600 watts on this battery to charge this battery. So if you divide 600 watts by this, if you cancel out the watt, the watt cancel watt. 600 divided by 1,584 hour will now have 2.64. That means this panel can charge this our battery for more than 2 hours 30 minutes, which is about 2 hours 35 minutes or thereabout. Remember, I said if you use this 600 watt panel, you might have a lesser efficiency. So what I would recommend is you can go for, instead of going for 600, you can go for 800 or even 900 watts. And if you are going for 600, you can get one 600 panel or two, which is 300 watt, 2 pieces. Then if you are going for a 900 watt panel, you can go for 450 watt, 2 pieces. Okay, so this is the number of panels you need for these hours of time. But if you want your panel, if you are going for others panels, you will know that you will spend more hours and time when you are charging this battery. If you, assuming you go for a lesser number of panels, you will know that we increase this 2 hours, so maybe 3 hours, 4 hours, or even 5 hours if you go for a lesser panel wattage. But the higher the panel, the higher the charging current, and the faster the battery charges. And if the battery is not charging very well, it will affect the battery performance. So it's important that you know how these things work and how many panels you can use to charge the battery for a particular number of hours of time. Remember, the more panel, the lesser the charging time and the faster the charging of your battery. And if you are the type that as the battery is charging in the daytime, you're also using the battery, you can decide to go for more panels so that you will not overuse the battery during the daytime and be looking for energy to use in the night time. So you should understand all these things that I've done in this place from the beginning of this video down to this very end. So let's look at the last part of this sizing of the solar system. Let's look at the last part of the system. Remember, small panels, battery rarely hits 100% state of charge. So if you are using small panels, just know you will observe that the battery hardly charge fully. The battery hardly hits 100% state of charge. Right? So the second thing is incompetent charging will lead to the battery suffocation and equal short battery life. So if the battery is not getting that amount of charge on a daily basis, it affects the battery, leads to battery suffocation, and it's also equal to short battery lifespan. Then another thing we're going to look at is tubular batteries prefer long absorption charging. If you go for tubular battery, this one is for you. Tubular batteries prefer long absorption charging, not rush top off. It's not a place whereby you will be rushing the system and all that. But tubular battery prefers long absorption. To be absorbing the power little by little, not the power rushing into the system or into the battery. It doesn't work like that. So tubular battery prefers a long absorption charging, not rushed tops off. So this is the whole system. And if you want the system, if you want your battery or your solar system for one room to last for 6 to 12 hours, you have already known the size of battery that can last for 6 hours. Then you can double the battery or increase your battery bank. Unfortunately, you will know that when you increase your battery, you also increase your panels. On this system, on the appliances I talked about, you can use 1 kVA inverter. But if you are increasing your time, your energy backup, your battery, as you increase your battery, you increase your panel also. Because if it takes 3 panels to charge your battery for 4 hours, if you have another battery, you are adding 2 batteries now, you can also add 3 panels so that you can still maintain this charging time so that the 2 batteries can charge along the same time. So this is how the system works, and this is how to size your solar system for one room. In case you are saying for one room or one room self-con, and you need a solar system, and somebody's telling you must buy 10 panels, 20 panels, or big batteries, and others. So these are the things you need for the system. So if you are an installer or a DIY who is finding it difficult to calculate or size or do a design for a solar system, we are available for more trainings like this, physically and even virtually, which is online. So you can reach out to us. We'll give you more trainings for solar system. Don't forget to share this video. Don't forget to like. Don't forget to subscribe to this video. And if you have any video or you want us to record or create one video concerning any challenges you are passing through, reach out to us, drop it in the comment section, and we'll do that video and everybody will watch it. And we're also open for consultation, designing of different projects outside the solar system, and also installation of solar system. We can travel down to anywhere to install solar system, and we can work on any project of any kind, be it in school, in resident home, in commercial, in the hospital, in the government house, in any place we can do a design for solar system and install it perfectly. You can also reach out to us if you need CCTV camera installation or training or any materials. You can reach out to us, and we are always here and we get to cover even electrical design, installation and wiring, both commercial and industrial and residential. We are always available and we do all this work perfectly, and you can always count on us. It's affordable, sustainable, and reliable. Once again, my name remains Engineer Isaiah Omoibo, the CEO of Bonse Global Engineering Services. Hereby we do solar installation, CCTV camera installation, and electrical wiring system. So feel free to contact us if you need more training or need any of our services or our products. We'll get it across to you wherever you are in Nigeria and in Africa. Till I'll see you in the next video. God bless you.